Okay, so as usual, some small problems with technology, and yeah, having the slot after David, it's one of the hardest one to get, but I'll try to do my best and start following these guidelines. So, in terms of preparation, I'm more or less preparing for the last 20 years with this technology I'm gonna speak about. So that was the easiest one. The rest of them, I will see how they come along during the presentation. So as I was already introduced it by Simon, I'm still willing to give you a bit of more background about myself. So I'm practically a C developer, a computer scientist engineer. I ended up doing real-time communication back in 2002 when I joined a research institute in Germany, Fraunhofer Focus. And practically since then, I'm working more or less with the same project with maybe different names that you may not be aware of. I have a small slide about the history just to get everyone in the context. Since I left the institute quite a while ago, I'm practically living only from open source, either like development or services, and mainly focused on real-time communication, specifically on Kamailio as a project. The project itself has grown over the year, being used worldwide, including here by our hosts, Simon and Simon as a company. We actually have our own conference by now, Kamailio World, and as a consultant, I'm working for a small company called Asipto in Germany, Berlin, where I'm based. The title of the presentation is about secure telephony identity, the revised version, this still unshaken, but as I'm co-founder and the lead developer of the project, and during yesterday, the breaks and the evening, I had some people asking me a bit more about Kamailio, as it's kind of a new name for them, or a new project. I just plugged a few slides at the beginning. And also yesterday, Alan was speaking about this programmable telecom, and we saw yesterday also from Simulike API, just to give you some ideas about what you can use to make Kamailio more flexible and adjust it for your needs. So summarizing again, it's kind of pretty old project outside, getting closer to 20 years of development. So we have quite a lot of extension. We cover a lot of these features in terms of load balancing, list cost routing, extension towards voice over LTE, instant messaging presence, plethora of backends like SQL or NoSQL, radius diameter. So you can find all this in our project. What's important to have in mind, it's a signaling server, it's not a telephony engine. So think about it like SIP packet router, not a call engine that it's answering the call and then you can deal at the call level. You will have to deal with the SIP packets, but that gives us the flexibility to change the content of those packets, to scale in terms of routing, rerouting in case of failure and things like that. Well, also have support for the newer technology in the space like WebSocket for WebRTC. And for RTP, actually, we work with other or interact with other applications such as RTP Engine, which is developed in our ecosystem as a project by different developers, but they are tightly working together. For media relaying, sometimes because of the QoS, not traversal, but lately that RTP Engine added support for transcoding and a bit more rich media services. Anyhow, if you want to read a bit more, you have the link to the project. And again, I need to focus back soon on the main topic of this presentation. Actually, later today, you will have Fred, another developer of the project, presenting how you can use Kamailio more specifically to integrate it with Simud, so it'll be a bit more practical from that perspective. So it's why I'm not focused more on that. However, as I said, over this year we had some changes in the name or how the project was controlled and how it evolved. So it started as a SIP Express router. Maybe some of you heard of it. As no longer pointing. Back in 2001, 2002 was released as open source. Then we had to create a fork, OpenSCR, back in 2005. And in 2008, we ended up in a trademark issue. And now the name it's Kamailio as a project. And since then, we use this, which is now better protected in terms of trademarks and all these, legal aspects that in open source we are not that good at dealing with until we face some issue. Okay. More or less the same. Anyhow, back to the slides. Again, yesterday was about the programmable telecom era and APIs. And with Kamailio, as we started quite a long time ago, we have sort of a scripting language that we developed from scratch back again in 2001. There were not many options for like a well-established scripting language fast enough for real-time communication. Like it was Python, but was known to be slow. Perl even now is not suitable for this recurrent execution and so on. So we had to write our own scripting language. Bear in mind that actually at the Research Institute, it was not focused on telecom. It was focused on IP communication, and the team there was like computer scientists, engineers. They were not telecom engineers. So practically, we build everything with IP in mind and trying to have it as flexible as possible. However, since then, the world has changed. Everyone is more familiar with scripting languages and programming, like software is eating the world these days. And our scripting language reached the limitation in the way that we as a development team, we don't focus on building a very flexible scripting language. We want to build a flexible VoIP platform from this is better. From this point of view, we want to focus on real-time communication. So here you can see a basic example of our config file. We have route block, which you could consider as a function, and then this action or statements inside it. But everything like what we support, like string operation and so on, it's customized and it has to be some C code behind it. So as now everyone wants to integrate with external APIs, our scripting language could be limited on that. So we recently, almost getting to 5 years actually, we introduced what we call Kamailio Embedded Interface. And with that, you can build a SIB routing logic using well-established scripting languages like Lua, JavaScript, Python, Ruby. So it's way more flexible. We try to make it quite simpler from this perspective. So again, you will have here a sample of our native scripting language block, and the next one will be, if you are familiar with Lua, will be the equivalent. So we expose an API via a module KSR, and then function that allows you from the Lua script to control the SIP traffic in terms of authentication, adding, removing headers, sending out, setting for how long to send it out, and what to do if it fails to send to the first gateway, send to the second one. You can do everything from Lua. And the same would be also like Python. I just give it the same example, but written as a Python script. And if you have a need to integrate the Kamailio with the Simud API, let's say a call is failing or there is no more memory, you can use the API for sending an SMS directly from the Kamailio config file. I'm sure Fred later will show some more example on this one. I just wanted to highlight or introduce you to the fact that now you can use any scripting language that you want if you feel more familiar with one of them. That would be the introduction to Camaillo. And again, if you need to learn more about, I was still here up to afternoon, more or less, so during the lunch break and so on. And you can join also our forums because we are a lively community and so on. Not to stretch it too long, I'm coming back to the original topic, what I wanted to present from the beginning. It's this stir and shaken, which is the terminology used for what's known as secure telephony identity. Now, again, I'm kind of very technical, so I might not really follow David's suggestion or recommendation on some aspects, but as I was trying to investigate or see what was the origin of this acronym, like STIR, it's quite simple. There was a previous iteration of this secure identity specification. In Camaillo will be auth identity module, but it was revised. With Shaken, actually, I discovered on Wikipedia that it was like some, the ITFs guys, sometimes they have this, like trying to find maybe not always the right name for some extension, like maybe everyone is familiar with zip simple, right? It was the right naming for what they did there or not. But here it's practically related to James Bond, and they kind of abused in a way or another to come up with the acronym. So they tortured the English language to get shaken out of this long terminology. Anyhow, if you are technical and you want to look more into the specification, you have the links here to start with, because there are actually a couple of RFCs. I spent the time to read on them, and at the end it's just about some JSON web token that you have to create, sign, and then verify. The simplified view here, it's practically about how the destination user can verify that the original caller is the one that pretends to be. To be honest, in Germany or a couple of countries I'm more familiar with the system in mainland Europe, to put it like that, there is no issue on robocalling and spoofing caller ID. I understood that here in UK it's so-so. You can face some robocalling and so on. The big market for this extension, it's actually in USA, where they enforce it. They started to enforce it via regulation. They made it like into a law, because in USA it's very common and actually very annoying, all this robocalling market and so on. So with this extension, practically the providers will add a signature into a SIP header based on their level of attestation of the caller. And there are a couple of levels, like full attestation. It's in the case you can certify for sure that the caller is the one to pretend to. Would be like a subscriber to your Asterix or to your FreeSwitch or to your Camaillo, and you ask for the password is verified by the server, then you know is the user. Of course, could have been a compromised user, but from that point of view, it's something that you don't concern at that moment. Then you can have the partial attestation, because, in telecom and in the VoIP world, we still interconnect, and we have smaller telephony system running by the companies connecting to bigger providers and so on and so forth. So you trust somehow the entity that registered to you as a PBX, but behind that PBX could be different extensions, different people that you don't really authenticate. You give a block of numbers to a customer, and you trust the customer as a whole, but not the individuals that use the numbers. And then the gateway attestation, or the level C, the lowest in terms of trust, it's when you get interconnected from PSTN. You get a call, I don't know, from Nigeria just to ask for your account to ship or to transfer those billions that were sitting there and nobody wanted. You trust the gateway because you interconnected with who is your peer there, but you in PSTN itself is no way to do further authentication. Now, based on this attestation level, the receiving party has to decide whether to accept the call, reject the call. Could be done at the provider level, could be led to the callee device or app. When you get like unknown caller ID, right now many of us just reject it. Maybe in the future the app will show this is certified attestation level A, B, or C, and it's up to you to decide to accept the call or not. So this would be, again, from SIP point of view, it's just creating a new header, SIP identity header based on JSON Web Token, JWT, with some signature based on cryptographic algorithms. Actually, here I made it a bit like a simple diagram, but there are a couple of other entities that you'll have to involve in your picture. This I took it and created the PKI because they put it. And I will have actually the slide discussing, and I wanted to highlight it from here, the complexity and the challenges that could be behind this. It's not about like technical challenges like algorithm to implement it. It's more like management and infrastructure that you have to maintain because of that. So a SIP identity header is not that small in size. So this would be a partial invite. Probably many of you, again, it's kind of a technical from this point of view, are very familiar with this structure. A lot of other headers could be after it, plus the SDP, the session description protocol. So this will be the SIP identity header that the first provider will have to build based on the ways it could authenticate the caller. And it's actually made of couple of parts. You will see there is some dots here. And actually I tried to make it in colors to be easier to spot the parts involved in this header. So there are practically 3 of them, plus some usual SIP header parameters like this info equal value, semicolon, algorithm, and PPT. These are like header parameters. This would be the header body, which is composed from 3 parts, and they are known as header for this value, payload for the GWT value, and the signature. The green one would be the signature, which is built with cryptographic algorithms over the first 2 parts, the header and payload of the JWT. The value here, it's actually base64 URL encoded. So it's a variant of the base64 if you are familiar with that algorithm, by replacing some, if I'm not wrong, the slash and the underscore. They'll replace with, the / and another character they'll replaced with dash and underscore, because slash it's used for paths in URL and cannot be part of this value. So it's only about the dictionary used for building this value with 2 characters which are different. What's behind this? Because you can just take it and use like command line to decode it. And it's a JSON. Practically, this will be the header part. What's here in the bluish color would be this JSON document, which has a set of attributes, algorithm, the PPT type, and the URL to the certificate that was used to sign and actually generate the signature based on it. Then would be the payload, which is actually having the information from our point of view related to telephony and the call itself. So it will be attestation level, A in this case, destination numbers, and could be many in some cases. When the signature is built, because based on it you can decide as receiving party, I trust it only for half a minute or 1 minute if it's coming older than this, just to prevent these reply attacks. And this will be the caller who it's calling it. And a reference to back to the originating provider. This is kind of unique idea that you can use as reference. But from like caller point of view, and call will be the destination origination fields here. It's about telephony, so they decided to use this E164 format, the international number without prefix. The time here is the Unix timestamp, the usual we have in communication. Attestation level again, here to refresh about A is the best that you can get, and C is when you should be careful in terms of I trust it or not as an origin. The signature, if you try to decode it, will be some binary. It might not even print properly if you do it via command line. But as a formula here would be, again, base64 URL variant of the ES256. So this is elliptic curve algorithm that you find in many of the encryption libraries like libSSL, for example. And then over the JSON documents that we had here over this one and this one. So first we make this base64 URL, and then we build the signature with the private key, and the URL to the public certificate corresponding to that key will be given as parameter to, or as a value to the info parameter. So receiving party will have to download the certificate, whatever link is there, do more or less signature verification, and if it's okay, then we'll trust the value in the attestation level. We'll, of course, has to match the caller query to be sure it's not a reply attack, it's not a call that is reusing a value from another invite unrelated with this one. So there are some extra checks that we typically do anyhow in Kamailio config file or asterisk, comparing values from headers. These are more for extension, and actually the algorithm and the PPT right now they have like must have this value, but in the future might be new algorithms to be enforced here. Maybe when the computing power is increasing, this algorithm is not going to be as secure as it's considered this day. So this is from the point of view of technology. I created another open source project, which is Secure SIP Identity Extension. It's hosted in Asipto organization on GitHub, but it's all open source. It has actually 3 components. It's a Go library, what is the common function, then actually code to deal with the JSON web token, to deal with the encryption, decryption, checking the fields, values, and so on. Then there is a wrapper library to export API towards C, because Kamailio it's a C, and I wanted also to have a module in Kamailio based on it. And then a command line tool that includes also an embedded HTTP, HTTPS server, so you can actually have it running as an API server from this perspective. I wanted also because, for example, in Kamailio we can do HTTP query. We have an HTTP client that you can use in our scripting language for maybe 10 years. So even for older version, I don't have to backport my new module. I can just use it with the HTTP client in that version. because everyone knows typically in telecom is quite a conservative approach. Not everyone is updating as we release new version, and I'm trying to follow my customers. Being in Go, practically you can run it on Mac OS, you can run it on Windows. I haven't tried, but Mac OS and Linux should work for sure, being portable from that perspective. I was looking at Golang also from the perspective of being the lead developer of Camaillio, an application which is written in C. We could see that the new generation is not really going that much in writing C code, learning C code. They look to higher level programming languages, and I wanted to prove that we can write like library or whatever extensions in Golang or another programming language that it's more attractive for the newer generation, and then easily just create in maybe 50 lines of C code the module in Camaillio that is completely reusing the code. So that was why I was looking first at building something in Golang and then using it in Camaillio and building a module for that. As I mentioned, there is an API service, so you can start it, and if you have your cluster of Asterix servers, you can connect for all of them to the same SIP ID application daemon. Sometimes, at least I'm doing a lot of troubleshooting, so it would be easier to just copy and paste from the ngrep output, the header, and then decode it from command line. So it's why I had also the CLI version for it. So as DevOps, that could be handy. And I thought, it's at the beginning as a technology. I couldn't see any other library out there. There were a few projects like FreeSwitch that started. I'm not sure about Asterix to implement it. But I thought it's making it more open to the entire community to use it and contribute instead of everyone writing specific code for each application that we have in the ecosystem. And again, integrating with older deployments via just HTTP clients should be easier from that perspective. Just the examples here. So practically from the command line, you have the binary that together with some parameters, you specify the color, COLI, what attestation level you want to do, and the paths to the certificates to be used, like private key and public certificate, to refer in these info parameters or the URL parameters for the next hop to check it. You can start it as a HTTP service or HTTPS by setting this HTTP SRV as parameter, giving the port. You can also give the IP to listen to. For the HTTPS, you'll have to provide, of course, the HTTPS, like TLS keys for connecting to this application, not the one to be used for signing the identity values. And to test it, this is using the usual curl application tool from the Linux. Just to give you an example, like, okay, you can store the value of the identity header in a file, and then you push that directly to the HTTPS or HTTP service that's running for you. Could be on another system. I just use localhost here, but you can have a centralized daemon running for this service. Or you can give it like a comma-separated list in this format. So this is just the prototype. Here would be with some values, and then you get back the full header value, and you just attach it with normal string header operation in your application, being it Camaillio or FreeSwitch or Asterix. In Camaillio, we have the module called SecSIP-ID, secure SIP identity. So I switch from the standard secure telephony identity to secure SIP identity for the module in Camaillio, because we do only SIP. Telephony could refer also to H323 or other protocols. So I thought to make it a bit more specific to Kamailo. Right now, it's a very simple interface. You have to say for how long to trust the signature. Again, there is a timestamp, and if the timestamp is older than now or older than 10 minutes ago, then I don't trust that, because could be a reply attack. Of course, depending on your environment, you can make it a shorter interval or longer this trust. And the timeout, it's about when having to fetch the certificate used by the previous hop for building the signature, for how long to try it, because you don't really want to get stuck forever there. And I'll have a slide about the challenges that this technology itself exposed to your telephony service. In our routing block, so this is again with our native scripting languages, we actually expose only two functions. Will be checking an identity header, giving the path to the certificate, if you cache it or if you download it, or if you don't give it, practically the module itself will download it from this header. Is the info parameter, which has to be also inside the GWT token. So it's why here I have two variants. If you don't give the path, we'll download it. And the second one, it's when you want to build it. So you'll have to give the caller ID, callee ID, the level you attested. Then would be this origin ID, if you want to give the reference. Otherwise, the module will generate a unique ID string using UID library. And then the path where the public certificate corresponding to the key, it's available. So we'll create now the identity header and we'll put this reference to it. And then the path to the private key that you use to sign the header. And this is practically yours. It has to be somewhere on the system. You can skip it, and then we'll use the one from the library, some default path, but probably you can provide the path directly here. You can see this $something are variables in Kamailo, and they are expanded. So practically you can make it per domain, you can make it per source IP if you download certificates and cache it for different purposes. So now, from my point of view, the technology is very simple. With Golang was like really straightforward to implement, because they have embedded HTTP servers, like 1-2 lines of code there. They have full cryptographic functions there. You just import it from the core function of the language, Golang, and then you hash it. It's way simpler than doing it in C from that perspective. But then, as I said, technology is simple, it's straightforward, easy to understand, but is not the only thing that you have to take care of it. So it exposes to a couple of challenges. Will be scalability and attacks from my point of view. We have there a URL pointing to a certificate that you download. So you have to download that before knowing that it's a legit call or not. And if it's a bad actor, can put invalid domain there, can put a domain that it's the DNS is not responding that fast, and that could add delays to retrieving the certificate. Then you as a provider, maybe you have a lot of traffic and you don't want the next hops to query you every time, because it's putting a lot of load on your systems at some point from that perspective. And then it's also a question which is not clear from the specs. Now we have originating and terminating providers, but in the middle could be different hops, like interconnect carriers. Should they just propagate it further, or they should reuse the header or add another one? So it can add a bit of complexity based on how you decide to do it and your role in the path of the signaling. Now with the certificate, this is global. It's about the certificate authority. Now one was designated, but that means they control, if you get in bad relation with who controls the certificate authority, they may not issue or sign your certificate, so you are not trusted. It creating a bit of problems from this business point of view. But then if they start spreading to other certificate authorities, do we trust them, all of them? Because right now, like, let's say you can use a certificate issued by Let's Encrypt. That's very easy to take, right? You buy a domain, it's cheap. It's how much level of trust you have in those certificates. Because right now, actually, they are used for encryption more than identifying the person. And again, there were a couple of other technologies in the past that were really great as concept and simple, but failed because of this centralized or who controls the infrastructure, like Enum. Probably everyone is familiar with that. It's a basic DNS. Behind it, DNS query, but nobody, they were not getting to an agreement who is maintaining these DNS entries, because DNS is typically controlled by internet companies, numbers are by telephony companies, and it was like a clinch between them. Then locally, you'll have a certificate management overhead. You know, you have employees that leave the company, then do they have a copy of your private key? Do they can sign out any call that they do in name of you? Then when you do caching, because you don't really want to query for every call, typically if you are interconnect carrier, for how long, how you check the revocation for it. And then if you have a big platform, do you locally or inside the company use the same certificate, or for each node you use a different certificate to sign, and then you have to make all of them available for download by the next hops? So it's all these kind of questions, again, not really related to the technology and signing the identity, but operating infrastructure that it's required. And also from business point of view, as we could see also with IPv6, the adoption is slow because there is no really business behind it. So maybe in US, at the pressure of their customers, they have to implement it. But here in Germany, if I have to interconnect with US and I have maybe 3, 4, 5 calls per day, do I bother to put all together this infrastructure, or maybe I just go via Simud or another one to just save on cost, and maybe not as financial cost, but again, infrastructure, operational cost, and so on. And also it's a question whether it's a bit too late for it. As we know, the younger generation went to messaging quite a lot, so even would be demand from the customers could be maybe not the future part of the customers from that perspective. And then I haven't really studied that much, but my impression is not really solving it as like completely, because right now it's very easy to buy numbers. If you want to just do robocalling, you go, I don't know, Simud has it probably, and Twilio and next one, whatever, you go there on the web, you buy a number in 1 minute, and you can use an asterisk to flood it. Domain, it's also very easy to buy. And then trusting, it's maybe not as, let's say, sure as you would think it has to be. But this probably has to be a bit more investigated. And then there was already kind of a trust relationship in place, because I cannot really send traffic to Simon if I don't have an agreement. And in agreement, it's probably written that, yeah, I have to send only good traffic from trusted persons. So I think in Europe that it's better regulated. It's why we don't see caller ID spoofing as much as in US. So could be a problem also of the basic laws or the main legislation rather than just communication authority enforcement or specific rules. So again, this it's still to open for the discussion and could vary from country to country. To conclude, actually, even if you do this, and I got it from an, here you have the link, it's extract from a New York Magazine article on Stir and Shaken like 2 years ago, more or less. So even if it's a trusted phone and the identity is asserted by the provider, behind it could still be a bad actor. Could be someone that tries to sell you something and is not going to deliver. So you still have to do the human kind of selection afterwards and decide, hey, that's a legit call, that's something I trust or not. So it's, again, the human layer is still very important. Even the technology is trying to help you to identify a fake or not call ID. With that, I'm kind of ending, but before I actually want to thank Simon, because it's one of the companies that support our project for many, many years. And it's what I like with small events, or let's say medium-sized companies. They actually promote the project, they speak about the project. It's not like the big telcos that maybe I do consultancy for them, but they ship me 100 pages of legal requirements that I cannot breathe. I did some work for them. But then some from their company is asking a question on the mailing list, and if you search on LinkedIn, you see it's employed on that big company. So they kind of come back on the community, but I cannot say it, but it's easy to discover, hey, why this guy from this big company is having a question about using Camaillio with 100,000 TLS connection. That's not what you do at home. But anyhow, thanks, Simon, for all your support, and thanks for this event and the opportunity to speak here. If you want to learn more about Camaillio, approach me, or if you have a chance and the global situation it's good at that time, you can join us in Berlin for the next Camaillio World, where last year we were like 170 people and about 30 to 40 sessions along 2 days and a half. Thank you, Simon, just to finish with that one. Thank you.